Hello everyone, I'm Vikas Shukla from referencedesigner.com, and in today's video I'm going to talk about the career opportunities for an electronics and electrical engineering graduates or to be graduating. By graduating I mean in the Indian context of doing their BTech or BE degree, and how they are going to choose their career. And it's very important because by the time we are in the third year or fourth year of an electrical engineering or an electronics degree, we just follow what we just follow is maybe a campus interview and grab whatsoever opportunity that is available to us. And most of the time our immediate attention is not on what that job is going to do for me in future, maybe 5 year, 10 year down the line, and then we are stuck with whatsoever we are doing the initial 2 or 3 years of the career. So what I want you to do is to take this opportunity of my experience, of my knowledge of working with different companies, and what is best for you. So before going into the specific career opportunities, what you may have a better career opportunity, there's one thing I want to point out, and it is that you should choose a career which is not much more difficult than what your capability is, because then you will not be enjoying it. You don't want to choose a career which is much harder than your capability, or much simpler or much easier than your capability. Then that you will get bored. What you want to do is choose a career which is a slightly more challenging than your capability, and only you know what your capabilities are. Are you very strong in mathematics and physics and electrical and going deep into the calculations and solving very difficult problems, or you don't like it, or you find it not very much enjoying? Then you have another. It's nothing that one career is better than the other, but it's just a matter of your preference. So let me start with this, that once you are about to graduate, there are industries that are very high paying jobs, and there are jobs that are not that very high paying. What it means in terms of it, and it not necessarily has to do with the money. It has to do with the demand and the supply. When there is an industry or there is a job that is very high paying, what that means is that there is a lack of available candidates for that particular job, or the candidates or those people, even though they are available, they do not get a lot of opportunity to get that kind of experience, and that's why they are ready to pay a high paying job. So I start with a high paying job and then move on to the low paying job, and then you need to see that if your interest or your capability matches those high paying jobs, and then if you are able to do that. If not, if it's looking too difficult to do that, then you need to move lower down the things, and you will be able to fit in somewhere. So let's start with the first one, and that is the chip design and chip verification jobs. They are very high paying. The only problem with this is only big companies make chips. For example, the Intel, the AMD, maybe Qualcomm, or all other chips that are used in cell phones, on laptops, on servers, and all those companies. But Samsung, maybe Apple, those are the bigger companies, they make chips. But the problem with this is very few people get the opportunity to work in those firms. And even if you work for like 1 year or maybe 2-3 years, the experience that you get gets a very good demand. Then you can switch over between those companies and get a very good salary and good recognition. So you need to think about whether you want to do that. Unfortunately, the 4-year electrical engineering or electronics engineering, those kind of jobs, they do not provide that kind of experience required to get those kind of jobs. So what do you do? What can you do to get into those kind of on the jobs? So for one, you are going to look for working in only those companies that work on chip design or that work on chip verification. What if you are not able to show some kind of any experience in those fields? So what you need to do is you need to learn a programming language called Verilog and VHDL. Well, in fact, so Verilog or VHDL, and I have in the description of this video, you will find a link where you can download the software and learn about the Verilog. So what you can do is you can spend like 1 month, maybe 2 or 3 months to learn the details of the Verilog and VHDL, and then try to solve some problem. Take some small projects in your mind, maybe like driving a serial port or maybe I2C bus. I wrote a very relatively complex program that has to do with the Verilog of VHDL. So these are used to, the software, the codes are used to design the chips. And then once you have done that, the next thing you could do is maybe you work on the real FPGA, get one of the FPGA evaluation board, and I will try to put those links to those FPGA board in the description as well. And in this field programming gate array, it's an actual hardware. It's not the real chip or the actual ASIC chip, but you can download your code into that FPGA and see that the whole code works in those FPGA environment. Once you have done these things, these you can do it during your third year's summer program, or maybe even after your fourth year, or during any time, any much time you can get in during the third year, fourth year, or any time you have. Work on those, and then once you have enough of your technical strength, you could go ahead and apply into the companies which has the requirement of an FPGA engineer or a Verilog and VHDL engineers. And fortunately, and this opportunity was not available in like 20 years ago, where, or maybe even earlier, where there used to be a course by CDAC, Center for Advanced Computing. I don't know if it still exists. So they used to provide you those kind of training, and once you do that training, you are good enough to apply for those kind of jobs. But with now, because of the so much of material available, and I will have my own set of the videos available in as a series of the playlist that you can go through, learn through it, and then apply for the ASIC or design experience. So one thing I would like to say that you need to have a certain level of ability to solve problems, to find out the issues, the problems in technology and those Verilog and VHDL. Only then you should do this. Otherwise, you will not find this job very interesting. Not everyone would find this job very interesting. Maybe only like 10 to 15 or 20% of the person will find this job very interesting. But this is a very high-paying job. So just give it a try if you start liking it. In the second category, I am going to put RF design, which stands for the radio frequency design. And what it means, the RF design means you will be designing kind of the things that is used in the radio communication. For example, in more recent things, we have 5G communication coming up. But also, there's a lot of demand in the defense sector in India or elsewhere in the whole world, where you could be designing the radar, but you could also be designing like Wi-Fi, Bluetooth, some other radio bands in ISM band, industrial, scientific, and whatever, what would that mean? So all those RF design is a very interesting field, and why it's high paying, it's also because it requires a little bit of your technological strength. For example, you should be good in electromagnetics, for example, in your RF designs, and the main reason why this job is high paying is because once you design the RF design, you need instruments, and those instruments are very expensive. We use like a vector network analyzers, spectrum analyzers, and many other. Only very good institutes or big companies have those instruments to be able to design that. We design power amplifiers, for example, RF power amplifiers, and so on and so forth. So it requires a certain level of technical competency, and only if you are good in calculus, in vector calculus, and so on and so forth, you like mathematics behind this RF design, and you are also passionate about this electronics and RF design, only then you should do this. Otherwise, you can pass it, but still, it's another area which is very high paying, whether you work in India or elsewhere. The third one I would say is signal integrity And by signal integrity, what I mean is, and I wanted to show you my own book here, The Signal Integrity for PCB Designers. That's one of my book. But the key point here is that what signal integrity means is that you are designing a cell phone, for example, or a motherboard for a cell phone, or a PCB for a laptop or a desktop or a server, or any communication, like Cisco makes a lot of communication equipment for gigabit Ethernet or 10 gigabit Ethernet or even higher speeds, things like that. So if, for example, the processor and the memory communication, it happens at a very high speed, and if the signal, the integrity of the signal is not very good, then the board will fail, or it will show intermittent failures, or it will have bit error rates. And then there's an optical communication. They also work at a very high speed, and the electrical part of it is working at a very high speed. So again, the problem here is you need to get to work with those companies that designs those signal integrity kind of products, and then you need to work with some signal integrity engineers. There are some books, and I am trying to put my contents of my book into a series of videos that you would like to go through and see that if you have interest into that, and if you something you would like to do. If you are working in this kind of companies, you probably should start a career which may be which is the product design, but the product has to be something which is a little more complex. For example, a cell phone design, or could be any other complex design. And from the product design, while you are designing that product, keep in mind the signal integrity in your background, and then try to see what is required in that product design from the signal integrity perspective. So you will need to have some kind of, not so much of, it's less technically challenging than the RF design, but certainly you will have to keep learning it, and you will need some experience. So if you have some product design and then you go through some of those tutorials, you should be able to apply for these kind of positions in product development, and then slowly, gradually move toward the signal integrity. It's still a very high-paying job, and it's very demanding as well. A good amount of requirement from technical competency. Product design is another area, and many of the electrical and electronics engineers nowadays, they switch to software field. They find it, because there's a lot of demand, they find it easier. But my thinking is that even if you have even slightest interest in electrical and electronics or things like that, if you are passionate about it, you should prefer or at least give it a try to do a product design, which means that there could be simpler products, anything that designs, maybe some embedded board design. For example, any electronic circuit that could be going into an air conditioners and Internet of the Things, or it could be a complex product, or it could be even a cell phone design product. What you will need to do is, when you start working in a company for a product design, you need to start learning the existing design, what their schematics is, how they look like, how they function, understand with your seniors how those designs look like. And then you need to also see how their layout, which is the actual placement of the components on the design, looks like. You will need to do a lot of simulation to do how the board will function. If, for example, A to D converter, under certain situation, you need to see how this simulation. We will be doing some simulation. What I want to tell you about that is, once you are doing a product design, you should have some hands-on. Hands-on means you should be, if you are passionate about the electrical and electronic design, you should be willing to pick up a soldering iron and do some soldering, connect few components together and see if you are liking it. And then you should be willing to use some tools to do a schematics, which is how do I draft a design, which is usually it's a little lower skill than your high-end skill. But if you are an engineer, I mean, you should be able to try your hands. And I have a full list of the videos of how to do a schematic design. You can download some free tools One of them is, for example, a KiCad tool, and do your schematic design yourself. The same thing for the layout, which is supposed to be a mechanical, a draftsman, but I believe that as an engineer, you should actually try your hands on those layouts, and I have the videos for that as well, and I will put those things. So once you have those kind of skills, either while during your study or just after that, you can learn those things, show it off to your companies in your CV. They will be more willing to offer you the job that they use, that uses product design or something like that. If you are not really, the electronics field does not excite you as much, or then you have and if you are more interested in doing software, but you also have a degree in electrical and electronics degree, then the embedded software is a very good field for you. Instead of going to the regular Java, JavaScript, Python, C, C++, and a lot of other those things, the regular software embedded web technologies, the PHP and all those things, you may prefer to do embedded software, which also use C, C++ to some extent. But this, when we are talking about the Linux software, the microcontroller, for example, smaller microcontroller that could be coming into, for example, an air conditioner or other IoT product. They use some software, and it's a very time-consuming thing to develop the whole software, mature it, test it, and so on and so forth. But if you can, so that microcontroller is relatively simpler. But if you want to get into slightly higher paying job, you could look into the Linux software. So in the Linux, you will be learning about the Linux operating system, to write device driver, how to use this device driver into application programs, and so on and so forth. You could be interested into the BIOS of the Linux. That's also another interesting field. And I will have some series on the Linux and all these things as well. So I gave you a brief idea of what you can do to fill in the gaps that industries are looking for, and your capability match this up. There's a big demand, and companies are finding it very difficult to fill up those positions, especially those that require a little bit of challenging things. And you may be lacking in experience, but you may have the mathematical background or aptitude for that. And if you learn or from my video series, it could be a very good opportunity where industry and the coming graduates can fill up those gaps. I hope you find this helpful. Now, once you decide what you want to do, you can go through many of those learning series, practical learning series in electrical and electronics engineering. Thanks for taking a look.